In our last video, we talked about electron configurations and how to write electron configurations. I want to revisit that just really briefly to talk about what the different numbers mean in electron configurations. So you had these examples, 1s2, 2s2, 2p6, 3s2, and 3p6 for argon. So what do those numbers exactly mean? So I want to break that down a little bit before we talk about shorthand notation. So when we're looking at 1s2, that 1 is our principal quantum number and it signifies our energy level. So it's telling us that we're in the first energy level if we have a 1s2 electron configuration. The s tells us our sublevel or our shape. That's our second quantum number, our angular momentum quantum number. So it's telling us our shape. So our S is telling us that it's spherical. Okay, P tells us it's globular, and so forth. And then that exponent up top, that 2, is telling us our number of electrons. So in 1s2, we have 2 electrons. In 2p6, we'd have 6 electrons. Use that information going forward so that we can draw shorthand electron configurations as well. So when drawing shorthand electron configurations, it's called the noble gas configuration. We haven't learned about noble gases yet, but a noble gas is a completely stable element. Okay? They generally aren't going to bond with anything because they are happy just the way they are. They're located in the last row of the periodic table. So our noble gases are in row 18. They include helium, neon, argon, krypton, xenon, radon, and so on. Okay, so those are our noble gases. When we're using shorthand configuration, these are our steps we're going to follow, and these are printed in your notes packet. You're going to use the last noble gas that is located on the periodic table right before the element. So for instance, if we're trying to write the electron configuration for aluminum, if we go backwards, the noble gas in front of aluminum is atomic number 10, which would be neon. So what you're going to be doing is writing that symbol in brackets, and then you're going to write the remaining configuration after the brackets. So you don't have to write anything before the noble gas. So it might look something like this. So for fluorine, fluorine is on the periodic table at atomic number 9. The noble gas before fluorine is helium, so you would write He, and then we'd start after helium going into the next column of the periodic table, starting with lithium, so 2s2, and then 2p5. So we're going to look at tin as our example. If we are looking at tin, tin is located on the periodic table at spot number 50 with periodic table symbol SN. So let me go ahead and make this bigger. Okay, so we're looking at tin. If we look at our periodic table here, tin is located right here. We need to find the noble gas that's before tin. So in order to do that, we're going to go backwards from tin. So we're going to go backwards, we're going to go up a row, and we see that krypton is right before tin. So what we're going to do is we're going to take krypton and put it in brackets as we start. So like this. So it's going to say that krypton is our starting location for this noble gas arrangement. Okay, so we're going to start after krypton then, so we're going to go down to rubidium. And rubidium, if we count down, is 1, 2, 3, 4, 5. It's our 5th period, so we're going to start with our 5s2 location. After that, we jump to our D block, and we know that our D block drops 1 level. So we fill in 4D10, and then we drop back up to 5p, and tin is in our second spot, so it would be 5p2. That would be our shorthand electron configuration for tin. So shorthand is much easier to use than using the whole longhand when you have to write out 2s2, 2p6, 3s2, 3p6, and all of that. It's much, much easier. So go ahead and practice magnesium and copper real quick for me, and go ahead and pause your video. Now that you've practiced them on your own, go ahead and check your answers. And hopefully these make sense to you. If they don't, make sure to reach out. You do have a lot of practice problems on this. Good luck.